and welcome to an algebra tutorial video learning about solving systems of equations using the elimination method. So step by step we're going to run through this approach right here, steps 1 through 8, and just go through and hopefully help you make sense of this method. We're finding the exact solution to two linear equations, but I want to know, well, what x and y value, what is that x and y value that makes both of them true? So linear system, we have two equations modeling some sort of situation, and I want to know, well, what is the solution? What point makes them both true? If I was to graph them, it'd be the intersection point. So that's where we're heading towards. We're trying to find that point of intersection. All right, so elimination method. If I want to use that method, the first thing, my goal is to add the equations together. So step 1 is to get them both in standard form. I want to line up the x's, line up the y's, line up the constants, and make everything all easy to add. This you can tell, the first equation, 2x plus 6y equals 6, that's in standard form. But this bottom one, I got some work to do. I got to rearrange that equation around to get x first, y second, the constants over. So to do that, I'm going to subtract 5x from both sides. I'm going to move that 5x to the left side of the equation with the y. But I want to move this 11, this plus 11, I don't want that there. I want to move it to the other side of the equation. So I'm going to subtract 11 from both sides. And you see what I end up having when I do all that is I still have my first equation. So I'm going to rewrite a whole new system. So I still have the first equation, 2x plus 6y equals 6. But now I have 3y minus 5x is going to be, I have negative 5x over there. And then I still have the 3y plus 3y. But I don't have this 11 anymore. So that got canceled out, turned to 0. So that equals 5x minus 5x turns into 0, and negative 4 minus 11 is going to be negative 15. There. I've got things lined up now. My x terms are lined up. My y terms are lined up. My constants are lined up. I'm starting to get something where I can easily add these things together. So step 1 is done. We put them both into standard form. I can start using the elimination method with this. All right, step 2. Now I want to look for opposites. I want to add these things together so that one of my variables turns into 0. And the only way to do that is to have opposites. Plus 5, negative 5, plus 1, negative 1. I need things that add up to make 0. So right now when I'm looking at this, I have 2x plus negative 5x. Those are going to add up to negative 3x, so those are not opposites. And 6y plus 3y are going to add up to 9y. So right now I don't have any opposites, so I have to do some multiplication to get them. So at this point, I want to try and think, okay, so what would be the easiest way to get opposites? So 2 and 5, I could multiply this by 5 and this by 2, and that would give me 10 and negative 10. That's one method. But then I'm involving multiplying both equations throughout to get that to happen. So that might not be the easiest. The easiest one to me would be taking this 3y and turning it into negative 6y. Then I would have a positive 6y plus negative 6y, and that would turn into 0. So to turn this 3y term, to get it into negative 6y, I need to take this whole equation on the bottom. I'm going to multiply both sides by negative 2. So I'm going to write the little negative 2 on the side there. I'm going to do some multiplying. Think big distributive property here. So all I'm essentially doing is taking the bottom equation. I'm going to multiply both sides of the equation by a number to make it a little bit more with what I want to help me get to using the elimination method. So I'm going to multiply by negative 2. Let's see what happens. So I got to multiply the negative 5 by negative 2. So I end up with 10x, positive 10x. Then I have plus. Then that negative 2 is going to multiply by the 3y to give me negative 6y equals, and then that negative 2 also multiplies by the negative 15 to get positive 30. So this would be, I want to again point out, make sure you're multiplying every term on both sides of the equation by whatever you want to multiply by. Strategically, I know I want to multiply that 3 to turn it into negative 6y, because now I have 6y plus negative 6y. That's what I want. But I can't ignore the 5 or the negative 5 and the negative 15. I have to multiply everything on both sides of the equation because I have to keep that equation true. All right, so now let's look at what we got. So now I've got 10x plus negative 6y equals 30. That's the same bottom equation. I just made everything twice as big and negative. But I still have 2x. I'm going to write that below it. 2x plus 6y equals 6. So it's the same system, and it's okay to move one on the top and one on the bottom. It's the same two equations. But now look at what I got. Now I have opposites, negative 6y, positive 6y. When I add these together, I'm going to get a variable eliminated. So we just did step 2. We had to multiply one of the equations by negative 2 to get two of the terms being opposites. Now that I've got them in standard form, now that I've got opposites, now we can add our equations together. Let's go ahead and do that. 10x plus 2x, I'm going to add those like terms, gives me 12x. Negative 6y plus positive 6y turns into 0. Good. That's why we call it the elimination method. We just eliminated the y variable, so I can now solve for x. And 30 plus 6 equals 36. And here, add the equations together. One variable is eliminated. Yep, we eliminated the y variable. Now we can easily solve for x. I'm going to divide both sides by 12. And x is equal to 36 divided by 12 is 3. All right. So in my solution, we just found that my point of intersection is when x is 3. I still need to find the y value. Don't forget, don't stop at this point and think you're done. I now need to do step 6. Let's back substitute and then do step 7. Let's solve for the variable eliminated. We got to figure out what y is. All right, so I know x is 3. I'm going to put it into this first equation and say, okay, 2 times 3. And now let's solve for y. Plus 6 times y has to equal 6. All right, let's solve that out now. 2 times 3 is 6, plus 6y equals 6. Oh, this looks interesting, lots of 6's. Let's subtract 6 from both sides. That turns to 0. So 6 times some number y equals 0. And if I divide both sides by 6, it looks like y equals 0. And that's okay. Don't feel weird at this point. 0 is a number. So that's an actual point, right? If x is 3 and y is 0, that's a point on the coordinate plane. It's actually on the x-axis. So there we go. My two lines, if I graph these two lines, you could do this just to double check. Again, I encourage you to use your graphing calculator or use a desmos.com, DESMOS. They have a great online calculator, graphing calculator that you can use. You'll graph these and you should see that they intersect at this point. So we just come to the x value, found the y value. We did back substituting, we solved. The only thing I've left to do is just to check. Let's check our workout. So I know x and y. We use this first equation over here to find my y value. So let's use the bottom equation then to check. So does 3 times y, 3 times 0, plus 11, does that equal 5 times x, which is 3? We're testing our solution out. Minus 4. 3 times 0 is 0, so 0 plus 11 is just 11 on the left. That's nice. 5 times 3 is 15 minus 4, and 15 minus 4 does turn into 11. So it looks like it all checks out into the other equation, and I'm feeling really good about this solution. All right, hopefully that was a helpful example. Getting a little bit more complicated and needing to arrange into standard form and to have to multiply one of the equations to get opposite terms that actually do eliminate when I add them together.